Taking a look at sectors of a circle. A sector is like a piece of a circle where we're looking at like the area of that little section. And so there's a couple of things that are needed when we start talking about sectors. The first thing is the area of a circle. Remember, the area of a circle is area equals pi r squared. That's how we find the entire area of the circle. And then moving on to this thing called a sector. Well, a sector is just a piece of the circle. So it's a section of the circle made by arc and two radii. In other words, it's like a pizza slice out of this thing. So when you look at a sector, the entire circle is a pizza, all right, is an entire pizza pie. The sector would just be one of those slices, okay? So that's what we're talking about. And the reason it's defined differently than something like an arc length is because it involves the arc, but it also involves the rest of this thing. It's essentially the area of that entire chunk, okay? So that's what we're talking about when we talk about a sector. It's a piece of pie. It's a piece of pizza here. It's that entire section of the circle, but it's a portion of the entire circle. And so when we talk about the area of that sector, okay, so the sector is actually the physical shape itself. The area is basically the space that shape covers. And so the sector area is a partial measurement of the entire area of the circle. So once again, just like we had with arc length, well, that was a fraction of the entire circumference. Now this is a fraction of the entire area. Or we could think of it as being proportional. So when we look at that sector, it's bound by a certain angle, a certain central angle. And what happens is the sector area and the total area are proportional to the angle measurement of the arc and 360. And so just like we had with our arc length, it's the same thing here. It's the partial measurement of area over the total area equals the partial measurement of the angle over the total angle, okay? And so again, it's a part of the entire thing. For example, if I look at something like this guy, it says find the sector area, all right? And once again, there are two ways that we can do this. I can do it as just a fraction of the whole thing, or I could set up a proportion. So let's start with a fraction. This is going to be a fraction of the entire area, so let's find the area. The area of the entire circle is pi r squared. And so as I simplify that, that's 25 pi. Once again, I'm just going to use 3.14 on my calculator here. So you get 78.5 square centimeters. But I don't want the entire area of this thing. I only want a fraction of the area. And the fraction that I want is represented by 72 out of 360 degrees. And so the fraction is still depicted based on the angle that I have. It's 72 out of the total 360 degrees. That's the fraction of the area that I want. So I multiply this. And it gives me 15.7 square centimeters approximately, okay? So that's option one. Option two is to set this up as a proportion. I still have to use that same angle, the 72 over 360, but now I say, hey, this area right here, I'll call it X. I don't know what it is, but that area of the sector X, when I compare that area to the entire area, it's compared to the 78.5. Well, that should be proportional to, it should be equal to the way the partial angle and the entire angle compare. So the partial angle is 72. The whole angle for the circle is 360, okay? So it's the area of the section over the area of the whole circle equals the angle of the section over the angle of the whole circle. And if I cross multiply and solve, I get the same value, okay? So those are the two ways you can set up. Either way, you need the 72 over 360.